Okay, so in this video we're going to be learning how to solve compound inequalities. All right, we talk about compound words, and they're two words put together to make one word. Now, an inequality that is compound is two inequalities that are smashed together in one math sentence to be one inequality. So two inequalities in one math sentence. Okay? So an example would be a very simple inequality of x is less than 3. Okay, that is a very simple inequality. You don't even have to simplify. All right, x is just less than 3. And x is greater than negative 3. Okay, that's one type of compound inequality. We're going to look at two words. We're going to look at and we're going to look at x is less than or greater than 3. I'm sorry, this is supposed to be less than. And this is supposed to be a greater than. So x is less than 3 and x is greater than negative 3. Or x, let's flip-flop them now. X is greater than 3 or x is less than negative 3. Okay, so we have two different inequality sentences here, and they both say different things. So let's talk about that. All right. Okay, so I've drawn out a bunch of number lines here that we're going to use to graph these inequalities. Okay, so the first one let's look at is x is less than 3. Okay, so we know that x cannot equal 3. It's not less than or equal to. So we're going to have an open circle around 3, and we're going to shade everything to the left because x is less than 3. Okay, so x could be any number less than 3 according to that inequality. X is less than 3. But we're looking at an and, so x is also, and x is greater than negative 3. So let's graph that inequality. X cannot be negative 3 because it is not greater than or equal to, so an open circle around negative 3, and everything to the right is shaded. But then we can read the whole sentence together. And we could say x is less than 3 and x is greater than negative 3. So I'm going to put these two graphs together. So I'm going to circle 3 and negative 3. This dot or this circle comes from this graph. This circle comes from this graph. And then everything in between is shaded. So x can be any number in between negative 3 and 3. Okay? And we talked about there's going to be two words, and or. Okay? In compound inequalities, we're going to see ands and ors. All right? So let's look at this one over here. X is greater than 3 or x is less than negative 3. So let's graph x is greater than 3. So we can put an open circle around 3 and shade everything to the right because that's greater than. All right. And then we can graph x is less than negative 3 because that's, we're going to shade to the left because left is less than. All right. Pretty simple stuff. Okay. Now, let's put the two graphs together. But do they meet in the center like this graph does? Like this graph met in the center down here. Would these graphs meet? No. And that's okay. They cannot meet. So we're going to put an open circle around 3 and an open circle, or I'm sorry, negative 3 and an open circle around 3. And I'm going to put this graph on this side where it goes. And I'm going to put this graph right here on this side where it goes. And there we go. They don't have to meet. So x is any number that is less than negative 3 and greater than positive 3. Okay, that's the difference between and or. Ands are going to meet in the center. Ors don't. Okay, let's look at a more complicated example. Let's say 2x is greater than 20, or negative 2x is less than or equal to 14. Okay, so we have an or. So are they going to meet in the center? Probably not. All right, so let's just solve the inequalities. Let's start with the 2x is greater than 20. We have to do an inverse operation. So the inverse operation of 2 multiplied by x would be to divide by 2, correct? And then, so we're going to divide each side by 2, and we're going to end up with x is greater than 20 divided by 2, which is 10. X is greater than 10. Or, we're going to solve this inequality. Negative 2x is greater than or equal to 14. All right, so we divide by the 2, negative 2 rather. All right, and when we divide by the negative, remember what happens to this? It turns into the less than or equal to. It flips over. All right, so we're left with x is less than or equal to 14 divided by negative 2, which is x is less than or equal to negative 7. Okay, so let's graph this then. We're going to have to make sure that 10 is on the graph as well as negative 7. So I'm going to start at negative 9 all the way up to 11. Okay, now let's just graph both of these. So x is greater than 10. Can x be 10? No, it cannot. So it's going to be an open circle, and we're going to shade what little graph there is to the right. All right, now that's that one. Let's knock out this one. X is less than or equal to negative 7. So it could be negative 7. So let's fill the circle in there and fill in everything to the left. It is very important to pay attention to the less than or equal to, greater than or equal to, and less than or greater than to make sure that you have your graphs correctly done. Okay, let's take a look at this right here. We have negative 12 is less than x minus 4, and we have another inequality tagged on to the end here. And it says that negative 12 is less than x minus 4 is less than 2. Okay, so what we're going to do is we're going to split this into two different inequalities. So we're going to use the symbols as a guide of how to do this. All right, so let's take a look at, let's start here, and then let's look until we can see we have an inequality. We have an inequality right there. So negative 12 is greater than x, okay? Or I'm sorry, is less than x. But we have to keep going because there's still math to do with the x minus 4. So let's go all the way to the other symbol, and let's say that negative 12 is less than x minus 4. So that could be one inequality. So we'll say negative 12 is less than x minus 4, okay? Or slash and, what's the next inequality? We can start at this symbol. Since we've already used it, we can get rid of it. And we can say x and go all the way to the end. Minus 4 is greater than or less than or equal to 2. Okay, do you see how we separated that out? So I used this part right here for this one, and I used this part right there for that one. You have to look to see where the inequalities separate. And usually it's going to be right at the inequality symbols. Okay, so now we can solve the inequalities with inverse operations. So the only inverse operation that we have here is to bring this 4 over to the other side. So we say negative 12. It was a minus 4 over here, so it's going to be a plus 4 on this side of the sign x, because when it switches sides, it switches signs. All right? So negative 12 plus 4 is less than x. So negative 12, go in the positive direction, 4 is going to be negative 8 is less than x. Okay, and slash or, let's solve for this inequality now. Again, let's bring that negative 4 to the other side of the inequality. And let's say that x is less than or equal to 2 plus 4, because when it switches sides, it switches signs. So x is less than or equal to 6. Okay, so now we can graph this inequality. And I'm going to count by 2's in this number line. To just make it a little bit easier. Okay, so let's graph this inequality. 8 is, or negative 8 is less than x. I like to just flip it over and say x is greater than negative 8. So x cannot be negative 8, correct? So an open circle around negative 8. Okay, and let's graph the other circle next. And x is less than or equal to 6. So a filled in circle on 6. And then we just shade in between, because x goes this way, x is greater than 8, and x is less than or equal to 6. So we shade in between, because this one would go this way on the graph, and this one would go that way on the graph. All right, so they're going to meet each other in the middle. Okay, let's look at one more example, and we're going to say negative 5 is less than or equal to x divided by 4, which is less than 5. Okay, so let's split the inequalities up. Okay, the first one is that right there. Negative 5 is less than or equal to x divided by 4. So we're going to stop right before we get to the other inequality symbol. All right, so negative 5 is less than or equal to x divided by 4. And the other inequality is x divided by 4 is less than 5. All right, so let's graph these, or let's solve these rather. So the inverse of x divided by 4 would be to multiply each side by 4. These 4's cancel out, and all we're left with on that side is an x. So what is 4 multiplied by negative 5? 4 multiplied by negative 5 would be negative 20, because there is a negative in the multiplication problem. The answer is negative. Okay, so that inequality is solved. Now let's look at this one over here. Same inverse operation as before. Multiply by 4 on each side. That 4 cancels out with that 4. All right, and then we're left with an x is greater than 5 multiplied by 4, which is 20. And then we can graph. Okay, and I'm going to count by 5's on this number line, and I'm going to say 0, 5, 10, 15, 20, 25, and then negative 5, negative 10, negative 15, negative 20, negative 25. Okay, so I'm going to, again, the x is not first in this inequality, so I'm going to flip it, and I'm going to say x is greater than negative 20. So I'm going to put a circle around negative 20, And I'm going to fill it in because x could be negative 20. X is greater than or equal to negative 20. And it's going to go this way, right? But I'm not going to shade it in until I know that this one's not going to meet it. So I'm going to go ahead and I'm going to start to graph this one now. X is less than 20. So can x be 20? No. So I'm going to have a open circle. And I'm going to shade in. And x is less than 20. So go to the left. X is greater. Go to the right. And they are going to meet in the middle. And that is that graph. The graph does not go off of the arrows, it just stays on the number line. Okay, so x is any number. This says that x is any number between 20 and negative 20. If you have any trouble, you can rewind the video, watch it, take good notes, come back to class and we can answer some of your questions and work through these problems together. See you in class.